The next topic that we need to cover is acid precipitation. We want to be able to explain the causes of acid precipitation. We want to explain how it affects plants, soil, and aquatic ecosystems. We want to see some different ways that acid precipitation affects humans. And then we also want to explore different ways that countries are working together to solve the problem of acid precipitation. So what acid precipitation is, more commonly referred to as acid rain, but as you can see, it could be sleet or snow as well. So that's why we use the term acid precipitation. So acid precipitation contains high concentrations of acids. Typically, these acids are formed from the most common pollutants of sulfur dioxide and nitrogen dioxide, but any sulfur oxide or nitrogen oxide is going to be able to be dissolved into rainwater when it's condensing as clouds. And when it does, it forms sulfuric acid, nitric acid, also sulfurous acid. And then once it dissolves in the water, it's going to come down with the precipitation. It's important to note that these concentrations are not extremely high. It's not something that you feel in your skin or you'd be able to detect, but the acid precipitation, it affects things over longer periods of time. So this is the general process for how acid precipitation is going to form. You have your atmospheric gases and water. They combine with common pollutants of sulfur dioxide and nitrogen dioxide. Sulfur dioxide is released from the burning of coal that has a lot of sulfur impurities in it, such as pyrite, and nitrogen dioxide is formed from high temperatures that are often achieved in furnaces and automobile engines. And so it forms these two acids, also sulfurous acid, which is H2SO3, and those acids come down in the form of precipitation. We use pH to describe the acidity of a solution. pH can be thought of as the power of hydrogen ion, and hydrogen ions, what they are is they're just protons, and so they're very corrosive. And so whenever you think of the term acid, that's what you should think of is hydrogen ions. And so pH is a measure of the hydrogen ions or a measure of the acid. For the pH scale, every factor or every unit of pH is a factor of 10. And so since the lower pHs are acidic and the higher pHs are basic or alkaline, we could say that if we know that pure water has a pH of 7.0, if you had a pH of 6, then that would be 10 times more acidic than pure water. If you have a pH of 5, it'd be 10 times 10 or 100 times more acidic. pH of 4 would be 1,000 times more acidic, so on and so forth. Normal precipitation is roughly 5.6, and the reason why that normal precipitation is going to be slightly acidic is because there are gases in our atmosphere, like carbon dioxide, that contribute to a natural level of acidity. So carbon dioxide dissolves in water to form carbonic acid, and that's what allows rain to have that default lower pH, that default level of acidity. When acid precipitation forms, it could actually decrease it lower than 5.6 to 5 and even lower than that. So anything less than a pH of 5 would be considered acid precipitation. You could see this is a pH scale. Anything lower than 7, shown in red on this chart, would be acidic. Anything greater than 7 on this chart, shown in blue, would be basic or alkaline. And you could see rain. We have this little bar up here. Rain typically falls between 3.5 and, or I should say it's typically 5.6, but it can be as low as 3.5. You can kind of see the different levels of acid rain here. Anything between 3.5 and 4 would be considered extreme levels. Between 4 and 5 would be just your average acid rain, and then between 5 and 6, that's somewhere in the realm of what you would call normal. 5.6 again being the value for your typical precipitation. Tap water is somewhere in the range of normal rainwater all the way up to neutrality at 7. Human saliva also near 7. Milk near 7. You could see some other examples of acidic substances: tomato juice, carbonated soft drinks, vinegar, lemon juice. They all have pHs that are lower, significantly lower than 7, so between 2 and roughly 4.5 for all of those examples. Some examples of things that are basic would be human blood, seawater. Detergents often have a lot of the used bases as what allows them to act as detergents, and then household ammonia is extremely basic, the common cleaning product. Acid precipitation is going to vary depending on the region, because the air quality varies depending on the region. So in North America, pH has been recorded as low as 4.2, but conditions are improving because we are largely past our industrial revolution phase of our country. So therefore, air quality is getting better as we move away from manufacturing. China and India, on the other hand, these fossil fuel emissions are on the rise, and their acid precipitation level is going to be a growing concern for many years as they are in that industrial revolution phase, and that phase where more and more people are able to afford vehicles that use internal combustion engines and contribute to these pollutants, nitrogen dioxide, sulfur dioxide, that are going to contribute to acid precipitation. Acid precipitation affects soil and plants. So acidification is the term that we use to describe an increase in the level of acid in soil and water. Some nutrients get dissolved and wash away with rainwater because of the level of acidity. There are many minerals that are in the soil, or nutrients in the soil, that are more soluble in acidic conditions than a more neutral condition. Therefore, when it rains and this rain has a lower pH, it's going to wash away all of these important nutrients. In some cases, it can cause different metals, such as aluminum or other toxic metals, to be released and absorbed by plant roots, which can cause root damage. And then sulfur oxides, mainly sulfur dioxide, dissolved in water vapor. This can clog the pores on the surface of plants, and this makes it more difficult for them to undergo photosynthesis because they can't take in carbon dioxide. So these trees in a forest in Poland, they show the dramatic effects that acid precipitation can have on plants. So acid precipitation is not always this extreme, but when it is, it can have a devastating impact on plants. Acid precipitation obviously not only affects plants, but it affects aquatic ecosystems as well, because if you have acid precipitation, that water, what starts in the sky, ends up in surface water as well. And so that also lowers the pH, so low pH can kill fish and aquatic life. It can cause aluminum to leach out of surrounding soil, and then aluminum as a metal can accumulate in the fish, interfering with their oxygen exchange, and this can lead to the eventual suffocation of the fish. The impact of acid rain is worst it's the worst in the spring because it rains more in the spring. So, and also in regions where there's snow, that's going to have it's going to be water that has a lower pH, and as that snow melts combined with the more rain, that leads to a significant impact or a significant influx of this acidic water, which is known as acid shock. So in the springtime, all that extra rain, the snow melt, that's bringing all that extra acid to the surface waters. We call that acid shock. What this can do is it results in fewer eggs that often don't even hatch, and then the surviving offspring have birth defects and cannot reproduce. And so living organisms, they're more impacted by acid rain in the spring. And so organisms that lay eggs in the spring, typically like fish or frogs, they would not any acid rain or this acid shock is going to be a very bad situation for them. So here is an example of a fish die-off along the shore of presumably a pond or a lake, and you can see that these fish, there's a good chance that they died from acid shock. Acid precipitation also affects humans because toxic metals such as aluminum and mercury released into the environment ultimately find their way into crops, water, and fish. The toxins can poison the human body. There's a strong correlation with respiratory problems in children. Decreased fish stocks can decrease the standard of living, and then forestry is negatively affected when trees are damaged. So whether it be our fish stocks, whether it be our wood supplies for trees, or whether it's affecting our children directly, acid precipitation can have an impact on humans as well. Additionally, a lot of our buildings and sometimes statues are made of materials that don't hold up well with acid precipitation. So concrete, marble, limestone, all three of these things contain minerals that dissolve in acid, mainly calcium carbonate. So since calcium carbonate is present in concrete, marble, and limestone, when it rains over time, if that pH is too low, that acid will react and it will break down that material. So some of the world's most important monuments, the Taj Mahal, various ancient temples, Egyptian and Central American pyramids, the Lincoln Memorial, these are all things that are damaged over time due to acid precipitation. Here you could see I have a picture of some gargoyles on a cathedral. You could see the acid rain damage right on the side of the face of this gargoyle. You could see how the different steps for how the acid precipitation is going to break down the calcium carbonate in these statues. Step 1, the acid rain or the dry deposition falls. A crust forms, so we have a chemical reaction of the acid with the calcium carbonate. The crust eventually washes off, it erodes off from action of water and wind, and then the layer of stone is removed. And here is another statue here on the right. The picture on the top was taken in 1908, and then the picture on the bottom was taken in 1968. So over the course of 60 years, we could see the incredible loss of detail in this statue due to acid precipitation. Globally, there are there's air quality agreements. We make efforts to have an international reaction to acid precipitation, because since air it moves around, obviously, if just one country is acting on acid precipitation, it's not necessarily going to cause a lasting impact, because we need all countries on the same board. So pollutants released in one area may fall as acid precipitation in another area altogether. So the US and Canada signed the Air Quality Agreement in 1991. Both countries agreed to reduce emissions that flow across the US-Canada border. Emissions have been dramatically reduced since the 1970s, and Europe has reduced by 40% since the 1980s. Developing countries such as China and India, there's no end in sight, because there's vast amounts of high sulfur coal still being burned in these areas to produce electricity for their factories, and burning fossil fuels in their automobiles. These things lead to the production of sulfur dioxide and nitrogen oxides, which only contribute to the acid precipitation. And so again, we see the general thread: the more developed countries, they are producing less pollution, and they're more likely to be on board with the air quality agreements, whereas the countries that are still developing in their in an earlier phase of their industrial revolution, they have a lot more to lose from these water quality or these air quality agreements, and therefore they're not on board with them, and because they're producing more pollution, they're going to suffer greater consequences of the acid precipitation. This is a global map of areas of high risk for acid precipitation problems. So the high risk areas are the purple areas. You could see There's parts of South America, Africa. Those are some major areas, some parts of Canada. Blue is areas suffering from acid precipitation problems. So China is a major one, the eastern coast of the United States, Western Europe. And then green are areas that are producing the pollutants that lead to acid precipitation. And so we see the areas that are producing in the United States are the Midwest and the West Coast. And then also we could see in Europe, it's more of a Southern Europe. So the acid precipitation is produced in the green areas. The blue areas are so the pollutants are produced in the green areas. The blue areas are the areas that experience the acid precipitation, and then the purple areas are the areas that are at high risk. And that's it for this lesson on acid precipitation. Can you explain how acid precipitation forms? Can you describe the harmful effects that acid precipitation can have on plants, soils, and aquatic ecosystems? Can you describe various ways in which acid precipitation can affect humans? And can you describe a way in which countries are working together to solve the problem of acid precipitation? That's it for this lesson. I hope that you learned something useful.